All right, so moving on to I think it's why we study all of this, and it's to use it for application questions. And then this is if you're going into the science um, route, you're going to be using a lot of these formulas that you have learned in this unit. And you're going to be using them day in, day out, especially when it comes to chemistry and biology. So here is how we use these formulas and how use these methods in solving word problems or in solving applications. So solve for x in the following equation. I have log base 2 of x minus 6 equals to 4 minus log base 2 of x. So this is similar to a question that we solved in the previous lesson. I want the log to be on the same side. So if I bring that log base 2x to the other side, so it's going to be log base 2 of x minus 6 plus log base 2 of x equals to 4. So you see now I have an addition between two logs and the same base, so I can write it as a multiplication. And that equals to 4. So now I can write it as an exponential form and I can solve. So that's going to be x minus 6 times x equals to 2 to the power of 4. And I can expand here, so that's going to be x squared minus 6x equals to 16. Bring the 16 over. And then now I can factor. So two numbers are multiplied to negative 16 and add to negative 6. So that is x, that would be negative 8 and 2. And that means x equals to 8 and x equals to negative 2. This solution won't work, so I have to get rid of it and reject it. And then that means x equals 8. The pH scale is used to measure the acidity or alkalinity of a chemical solution, and it is defined as pH equals to negative log of the concentration of H+. So where the H+ is the concentration of hydronium ions measured in moles per liter. And then we know that if the pH is 7, then it's neutral, and then anything higher than 7, it would be basic, and then anything less than 7, it would be acidic. So let's see. Answer the following pH scale questions. Tomato juice has a hydronium ion concentration of approximately 0.0001 mole per liter. What is the pH? So this is, they give you the concentration. It's as easy as, excuse me. It's as easy as plugging it into the formula, and the formula is pH equals to negative log of the concentration of H+, which is negative log of 0.0001, and that pH is equal to negative 4. So that equals to 4. So that's a pH of 4. Blood has a hydronium ion concentration of 4 times 10 to the power of negative 7 moles per liter. Is blood acidic or alkaline? So again, they gave me the hydronium concentration, so I have to write it in a formula. So if you do that in a calculator, that's going to give you a pH of about 6.4. So since it's 6.4, so it's acidic, right? Because it's below 7, so we can say that it is acidic. Orange juice has a pH of approximately 3. What is the concentration of hydronium ions in orange juice? So they give us the pH and they want us to find the concentration. So I can set up the equation as 3 equals to negative log of the concentration of H+. So in order for me to be able to solve, the first thing I need to get rid of that is that -1. So bring it over and becomes -3 equals to log of h plus. And since this is a base 10, so I can write it as an exponential, and it's going to be 10 to the power of -3 equals to the concentration of H plus. And that means that the concentration of H plus in the blood is equal to 0.001 mole per liter, or you can leave it as 10 to the power of -3 mole per liter. All right. So also the decibel scale. So if you are going to the physics as well, so some common sound levels are indicated on the decibel scale shown. The difference in sound levels in decibels can be found using the equation B2 minus B1. So that's the difference is equal to 10 times the log of I2 over I1, where B2 or beta 2 minus beta 1 is the difference in the sound level in decibels, and I2 over I1 is the ratio of their sound intensity, where I is measured in watts per square meter. So this is a difference in the decibel level is equal to 10 times the log of the intensity, the ratio between the intensity. Answer the following questions about decibels. How many times as intense as a whisper is the sound of a normal conversation? So if I go back to the previous one here, so a whisper and a normal conversation. So a whisper has a decibel of 30 and a normal conversation has a decibel of 60. All right. So if I go back here, so the difference between a whisper and a normal conversation. So that's going to be as 60 minus 30 equals to 10 log of the intensity of the second divided by the intensity of the first. If I divide by 10, so that's going to give me 3 equals to log of the intensity of the conversation over the intensity of a whisper. And then 10 to the power of 3 equals to the ratio between the two intensities. So that means a conversation sound is 1,000 times as intense as a whisper. All right. So what I did is I found the difference in decibels. I found that between the higher and the lower, then you divide by 10 because you have 10 times log of I2 over I1. So you divide by 10 and then you change to exponential because this is a base 10 here. So it's going to become 10 to the power of 3. And that would be the intensity. So how many times is more intense? So the sound level in normal city traffic is approximately 85 decibel. The sound level while riding a snowmobile is about 32 times as intense. Okay. What is the sound level while riding a snowmobile in decibels? So what they gave me here, they gave me the sound level in normal city traffic. So this is the sound level in normal city traffic. So that's beta 1, because what I'm doing here is the sound level while riding a snowmobile is 32 times as intense. So that means your snowmobile is your beta 2. Okay, because you're comparing I2 over I1, and then the intensity of the snowmobile is 32 as intense. So in this case, this 32 times as intense is your I2 over I1. Okay, and I'm looking for the sound level while riding a snowmobile. So I'm looking for beta 2. So I have beta 1 or beta 2 minus beta 1 equals to 10 log of I2 over I1. I know that beta 1 is 85, and I know that I2 over I1 is 32. So what I can do here is I can bring the 85 over, calculate the 10 log base, 10 log of 32, and then if I do that, 10 times log of 32 is about 15.05, and then add the 15. So that's beta 2 equals to 10 log of 32 plus the 85. So that's going to be about, if I calculate this, that turned out to be 15.05 plus 85, that's going to be about 100 decibel. Okay, so while you're reading these questions, make sure that you are reading properly, and you know how to identify which letter it represents. Another very important topic that we cover also and that deals with logarithm is magnitude and Richter scale. So when you hear in the news that there is a 5 earthquake, magnitude 5 earthquake, what does that mean? How intense is that compared to a 4? Or how intense is that compared to a 6? Or how intense is that compared to a 3 magnitude earthquake? So the magnitude of an earthquake is measured using the Richter scale, which is defined as m is equal to log of I over I0, where I is the intensity of earthquake being measured and I0 is the intensity of a standard low-level earthquake. So how many times as intense as a standard earthquake is an earthquake measured 2.4 on a Richter scale? So this is the M. So 2.4 on a Richter scale, so that's 2.4 equals to the log of I over I0. So usually in the news they give you that. But then to compare, to know how many more as intense as it is to a normal low-level earthquake, so what you're going to do here is you're going to write it as an exponential form. So it's going to be 10 to the power of 2.4 equals to the log to I over I0. And that's going to be about 251. So 10 to the power of 2.4 is 251.2. So the intensity, so it's 251 more as like times more intense. $251 times as intense as a standard earthquake. What is the magnitude of an earthquake 1,000 times as intense as a standard earthquake? So basically that 1,000 times is I over I0. And you want to find M. So you don't know what M is. So the formula is M equals to log of I over I0. So M is equal to log of 1,000. And that's going to be M is equal to 3. and that means the magnitude of the earthquake is 3 on Richter scale. All right, so make sure that you keep these formulas handy so you know how to solve the other problems or application problems. These are the 3 formulas that you're going to be using to solve these formulas, to solve these type of questions. So that's the end of this unit, and we'll be getting ready for a unit test sometimes next week.